Hello, everyone. Let's talk about this optimization problem that has a Norman window. And that's gonna still run just like the activity question. But the problem here is going to be that we have a mix of geometry. So we have a half circle and we have a kind of a rectangle. And we're asked to find the maximum possible area, given that the restriction for whatever metal or steel they use, maybe aluminum, I'm hoping not plastic, right? And that's gonna be uh, the constraint. But the issue with the graph that I don't like is whoever drew this did not just keep attention to that there is no metal here because you're making a frame, right? You're making usually these windows they go something like this arced and then you can put whatever some decoration or whatever or stained glass or something. So there is no metal here. So when we look at the perimeter, you have x and y, and going around the half circle. So the half circle around, we know going around the circle is pi d, which is the circumference. So this half, so a y and a 2x. And this is a 76 that we're given as a constraint. There is no d, which is a diameter. So the diameter is y. So this d is going to be replaced with y. Anywhere you think about d is going to be replaced with y. Or if you're thinking about radius, then it's going to be d over 2. So the radius is going to be y over 2, anywhere we need it. So half and 2x plus y equal that 76. All right, so 2x plus y plus pi over 2y equals 76. Looking at this, you see that if you're separating or factoring the y, it's going to give you this kind of fraction that will troublesome the work. So this will make us rethink what is the best way of doing this. We usually do it as area as a function because that's what we're trying to maximize is the area as a function of x. But you don't have to do that all the time. So here, this is where you kind of make a decision. We know the area is going to involve x and y, so it needs to be, let's leave it for now and just talk about the area that we're trying to maximize. And that area is going to be for this lower part is x times y. Let's call it area 1. And area 2 is going to be half of a circle, which is pi r squared. And r is going to be stated as half of diameter, which is the y in this case. All right. So that's going to give us 1/2 over times y squared times pi divided by 4. So 1/2 times 1/4 is going to be 1/8. So 1/8 pi y squared is going to be the second area. So all right. So here now we have x and y, and we need to decide if based on this, if I'm solving for x, it looks like you're just dividing by 2 and this thing stays. If I'm solving for y, you're going to divide by this and going to create you a problem. It's still doable. It's just going to create a problem because we don't want to round it from the beginning. We want to keep exact value. So here we will decide that maybe solve for x. And in this case, you have y, so this function is going to be in terms of y. This function that we need to maximize is going to be that way. So let's go back to this start. It's going to be 2x. And let's also put this together. So we just put 1/2 over 1/2. So 1 over 1, 2 times. So 2 plus pi over 2. If you do the common denominator, it's going to be a 76. So let's subtract this quantity here, and it's going to be 76 minus. So this, just think about it as a number for now, and you can know what it is. So we divide by 2, divide by 2, divide by 2. So x, 35 and 8. If you have a fraction, you divide it by 2. This is 2 over 1. So it's 2 plus pi over 2 times 1 over 2. So x is 38 minus 2 plus pi over 4 times y. All right, so the star becomes this now. Let's call it 2 stars. And we're going to use that into this function that we need to maximize. And it's just going to be in terms of y, so we can differentiate and set it to 0 and keep going with the same process with it. All right, so let's call this 3 stars. All right, so here is a x times y. Here is y, and x is going to be this one plus pi over 8 y squared. All right, so this is x. Now that's going to be replaced with that. So y, 38 times 2 plus pi 4 times y plus pi over 8 y squared. And of course, one thing gives the other. We need to distribute 38y minus this thing, y squared plus pi over 8 y squared. And we know what needs to happen is 38y is by itself. And we have to decide here how to do this. It depends, each one probably will do it different, but let's say I do plus here, and I do y squared here. So this is negative, means this thing is this way, and this one is this way. So if you put plus, means you didn't change anything, so you keep everything as it is. So yeah, so somebody will say that's pi over 8 minus. Let's be careful, just keep it the same way, because as soon as we want to combine, something is going to change because of the minus. Yeah, so now you see I need a common denominator, I need a 2 to have an 8, but this minus is going to be distributed, so that's going to affect all this stuff, right? So y squared is pi minus, and it's negative 2 times 2, which means negative 4, and negative 2 pi over all this common denominator. So you can pause the video here and try it and see how I got to this. Or if you've done it differently, see that you should get similar to what I will have now. All right, so we have negative pi minus 4/8. And we've done examples where you get a lot of negatives and you're like, maybe can I simplify? Can I make it better? Yeah, so if I have negative and negative, if I factor a negative, it will change this positive. So yeah, maybe that's a good idea to do at this step. But somebody, if they didn't do plus, they did negative from the beginning, they may run into that directly. But let's leave it for now and just say I have two negatives, so I factor negative. So negative 1. This negative 1 will become negative y squared. So a now is going to be 38 y minus y squared times pi over plus 4 already. All right. As you see, this a is a function of y. It's not a function of x as we usually do, because we're trying to avoid making things more complicated. It looks like the problem itself is already involving more things here and more ideas. And once we get to this objective function, then we are good to move with the derivative, right? So that's the goal. So maybe to pause the video until you see or redo these steps until you get to this. So the process we know, you have the objective function, you're going to move to a prime of x, which is 38y, minus, this is a 2y. I should put y here. I reinforced it, then I wrote x. It's not good. So, when you solve, you don't have to, but just I want, just show you what happens, how the function becomes a function of something. Even if you write a, so it doesn't matter, just a. So negative 2y, this is a number, right? That's a number. So nothing, it's not so no product rule, nothing happened there. It's just a multiple. And y squared is 2y. So someone will say, of course, why are we using y prime? So that's why I wanted to reinforce this idea. It's a function of y. So when you differentiate here, you're not differentiating with respect to x, you're differentiating with respect to y, right? So yes, you do have y prime, but it's dy dy, that's y prime, which is 1. So that's why I didn't put it. And this one will become same thing, y prime, which is dy dy. So it will go away, it just becomes 38. Just like if you have 38x and you say, what is the derivative? Then you say 38. Why? Because you differentiated with respect to x. Now you have 38y. It's going to become 38. Why? Because you differentiate with respect to y. What happens if you differentiate with respect to x? It's going to be 0 because it's not possible. If you do this is not a function of x. You're going to get 0. So it's important to keep track of differentiating with respect to what. All right, so this also becomes 1. So all the ones are gone. So a prime of y is 38 minus 2y pi plus 4/8, which means we can multiply the 2 inside or simplify a 2 with an 8. A prime of y equal 38 minus pi plus 4/4. All right, so we got the derivative, and that's nice. We know the next step is to set it to 0 to find the critical numbers. So 38 minus y, 5 plus 4 over 4 equals 0, means detach from subtraction. All right, we're looking for y, so we're going to divide or multiply. We need this thing, so I'm going to multiply by this. You see, it's easier when it's a single fraction instead of having 1 plus. All right, so this is out, and that gives me y equal 38 times 4. What's that? 152 over pi plus 4. Yeah, we're good. We got a y value. Of course, now you're going to use it, but if it's too hectic to use, or you have a scientific calculator that doesn't have many lines and stuff, you can use a good approximation, not a chopping one. You know, chopping means you just cut off, you decide I want to take round to 3 numbers and drop everything else or something. So yeah, based on my basic scientific calculator, I get this number. So that's the y value. I know what I need to do next. It looks like I'm gonna go back to the x value, right? Which is the 2 stars. Once I have the x value, I just go back to the beginning and say the 3 stars, I have a. So from here, it's just a matter of calculations. All right, so I'll pause the video here and I'll go to the next page and I'll write it down. Okay, so we go back to x and we put the y value that we found. It's 38 minus plus pi over 4 times the 21.283,767. Of course, you may use a good number like 6 digits and after the decimal, and that still works. But just to keep the point of not rounding them in the middle, I just use everything. So x is came up as 10.641. 88392. And now I have both values, then I put in the 3 stars that I have from the beginning. So just a matter of using a calculator. This is the x and the y plus 5 over 8 times the y squared. It's a small space, so that's a y squared there. And it comes up to be 4.439 meters squared. All right, so the recap for the process, you can pause the video and see. We're maximizing an area of a window and we're using, let's say, some metal and creating the arc of a half circle of a rectangle. So the perimeter is 76 using the half of the circumference and 2x and pi. That gives us, then I looked at the area. which is of rectangle xy, and half of a circle, which is half of pi r squared. Then it looks like x and y, of course, are in the area. Then I went back to that perimeter and I decided maybe x is better to use to solve for, because if I solve for y, I will have more stuff to use. So since I used x, the area does not have that substitution made a to be a function of y. And just to trace to make simplify until I came up with this area as a function of y to be this here. And because it's a function of y, when we differentiate with respect to y. And when we differentiate something of y with respect to y, the chain rule doesn't apply because dy is just 1. Or if you use the chain rule, it will simplify to 1. So y prime is 1. So y prime is 1. And that gives us a prime. The first derivative, we set the first derivative to 0 to find any critical numbers. Here it only gives a single number. And you will substitute in x. You get x. Then you substitute x and y in a. And we get the final answer, which is the maximum area that can be made with that to make this normal with that. Cool, thank you.